Welcome to this visual analysis. Today, we're opening up the case file on one of the absolute biggest mysteries in modern astrophysics. We're drawing directly from a really fascinating paper by João Carlos Harlan de Barcelos. We're going to break down an incredible alternative perspective on how our universe actually operates, and we'll visually piece together the clues right here.
You know, for decades now, standard dark matter has basically been the ultimate cosmic mystery patch. It's that invisible glue scientists always use to explain why galaxies hold together. But what if that invisible glue doesn't actually exist? Like, what if we've just been looking at the evidence all wrong this whole time? Well, today we are going on a bit of a cosmic detective story to investigate exactly that.
Okay, let's dive into this. Here's our roadmap for today. First, the enigma of dark matter. Then, the decreasing universe theory. Third, ultra-diffuse ghost galaxies. Fourth, the giant exception NGC 1277. And finally, the gravitational verdict. All right, let's kick things off with Section 1, the enigma of dark matter. So let's set up the foundational problem cosmologists have wrestled with for, half a century now. When astronomers look at standard spiral galaxies, they measure the speed of orbiting stars by looking at the redshift. Think of it kind of like a giant cosmic speedometer. But here's the problem. Stars at the outer edges appear to be moving way too fast. Based on the visible matter, the stars, the gas, the dust we can actually see, these outer stars should literally be flying off into deep space. To explain why they don't do that, standard cosmology adopted dark matter. It's basically a hypothetical missing mass that supposedly provides the extra gravity needed to hold the whole shebang together.
Moving right along to Section 2, the decreasing universe theory.
Now, what if there's another way to interpret that redshift data? According to the source paper, the decreasing universe theory, or DUT for short, offers a totally different paradigm. The theory proposes that space, atoms, literally everything is actually contracting. But here is the absolute key mechanism. This contraction rate is proportional to gravitational intensity. So stars near a supermassive galactic center, well, they contract faster. Meanwhile, stars out on the outer edges where gravity is weaker, they contract slower. And because they're contracting slower, the light they emit actually has a higher redshift. This difference in redshift creates the illusion, and I really mean illusion, that those outer stars are moving incredibly fast. And this brilliantly illustrates the original paper's premise, which proposes a pretty radical shift. Dark matter isn't some physical substance hiding out there in the dark. According to DUT, it's merely a perceived effect caused by a gravitational gradient. Basically, the steeper the difference in gravity between the center of a galaxy and its edge, the greater the difference in redshift, and therefore the more dark matter you apparently need to make the math work out. The original paper actually uses a set of equations based on a Jacobian factor to prove this, but let's translate that complex math into something a bit more intuitive. In a standard spiral galaxy with a really heavy center, the gravity gradient is high, so the apparent dark matter effect is high, right? But DUT mathematically predicts that if a galaxy has a near-zero central mass, or if it's so tightly compacted that its radius is tiny, that gravitational gradient essentially vanishes. Think of the gradient like a steep hill. If the hill becomes totally flat, well, the effect of rolling down it just disappears. And if the gradient vanishes, the dark matter illusion should vanish too. So the big question is, do galaxies like this actually exist? Well, let's look into that in Section 3. Ultra-diffuse ghost galaxies. Let's introduce the very first suspects in our cosmic detective story. Recently, astronomers have identified several completely bizarre galaxies that show a total absence, or at least an extreme scarcity, of dark matter. The most famous is this trio of faint galaxies aligned in space, DF2, which was discovered back in 2018, followed by DF4 and DF9. Another one is the ultra-diffuse dwarf galaxy AGC 114905. Over 40 hours of detailed measurements using the Very Large Array showed that its rotation can be entirely explained by visible matter alone. Zero dark matter required. No way, right? Now, what's really interesting about this is exactly what is missing. These galaxies completely lack the bright, dense central bulge that we'd normally associate with regular galaxies. In fact, they are so transparent, so diffuse, that telescopes can literally see other, completely different galaxies right through them. They're essentially cosmic ghosts. Because they lack a defined central region and don't have active supermassive black holes, their mass is just evenly and faintly spread out. Instead of a heavy core, they just have these isolated, bizarre globular clusters floating around in transparent gas. And if we connect this back to the decreasing universe theory, well, it clicks perfectly. Without a massive dense center, there is no strong central gravity.
No strong central gravity means no gravitational gradient from the center to the edge, and therefore, no dark matter illusion. This brings us to Section 4, the giant exception, NGC 1277. But, science demands rigorous testing. If the theory only works for faint dwarf galaxies, well, it's incomplete. So we're pivoting to the absolute opposite extreme. On one side, we have our ghostly transparent galaxies. On the other side, we have NGC 1277. This is a hyperdense, ultra-compact relic galaxy with a gigantic, massive core. Literally, they could not be more physically different. Yet, NGC 1277 shares one seemingly impossible trait with the ghosts. It also seems to have zero dark matter.
NGC 1277 is just an absolute anomaly. It's located in the Perseus cluster, about 240 million light-years away, and it's considered a cosmic fossil. It formed 12 billion years ago in a rapid 100 million-year burst, and hasn't interacted with another galaxy since. It is incredibly compact. We're talking only a quarter the size of our Milky Way, yet it squeezes 120 billion suns into that tiny space. All of its stars are ancient and red, and its star-making gas is entirely depleted. It's literally frozen in time.
And at its heart sits a true monster. The supermassive black hole at the center of NGC 1277 has a mass of 17 billion suns. Yes, you heard that right, 17 billion. To really put that into perspective and understand how absurd that scale is, just consider the proportions. In a typical galaxy, the central black hole accounts for maybe, 0.1% of the galaxy's total mass. But in NGC 1277, the black hole eats up an astonishing 14% of the entire galactic mass. It completely shatters the known rules of cosmic evolution. Because of its immense mass and density, standard physics absolutely predicts that NGC 1277 should just be swimming in dark matter, like up to 70% of its total composition. But detailed spectrography reveals a massive, baffling discrepancy. The observed dark matter is less than 5%, and astronomers admit it's perfectly possible there's exactly 0%. So, just like those faint ghost galaxies we talked about, the rotation of the stars in this ultra-dense powerhouse is explained entirely by the gravity of its visible matter. Standard models really struggle to explain how such radically different galaxies can both completely lack dark matter. But the decreasing universe theory steps right into this massive gap in standard cosmological expectations.
Which brings us to our final part, Section 5, the gravitational verdict.
So the crucial point is, how does one single model elegantly explain both of these extremes? Well, the DUT model neutrally accounts for every scenario based entirely on gravitational gradients. Step 1. Standard galaxies have a strong gradient from a heavy center to a light edge, so we see a strong dark matter illusion. Step 2. Ultra-diffuse galaxies like DF2 have no heavy core, meaning there's almost no gradient, so no illusion. And Step 3. Ultra-compact galaxies like NGC 1277 have a massive core, but they are so small and densely packed that the outer stars are still relatively close to the center. Because the radius is so small, all the stars share a very similar gravitational pull. The actual difference in gravity from center to edge is minimal. A minimal gradient means a minimal difference in redshift, effectively eliminating the dark matter illusion.
The decreasing universe theory offers this absolutely fascinating, unified explanation for galaxies completely devoid of dark matter. It bridges the gap between the faintest ghosts and the densest cosmic fossils. And it really leaves us with this final thought. If something as foundational as dark matter can be mathematically modeled as a mere illusion, what else in our standard model is just waiting for a change in perspective? It's a great reminder that the universe often requires us to look at the exact same data, just with an entirely new set of eyes. Thank you so much for joining this visual analysis today, and keep questioning the cosmos.